All right, guys, welcome back. We got a little short video today. Just again, another application of Pythagorean theorem and to the distance formula, which is what we've been learning about or learned about yesterday, or in the last video if you're following along in that order. So today we're going to talk about how to find perimeter of a closed shape with the following points: R, which is at the coordinate -3, 5, O, which is at the coordinate 2, 5, N at the coordinate 4, -2, and A at the coordinate -3, -6. Now, if you guys would like to pause this video and just attempt this on your own before I actually give instruction on it, you'll be doing a problem similar to this today. So I just wanted to kind of show you how the problem worked. But if you'd like to do that, you definitely can. And just, like I said, do your best with it. But we are going to work this problem out kind of beginning to end. So the first thing that I'm going to do is create a coordinate grid. Now, this is not required. However, it is helpful for setting the problem up. And then I'm just going to plot each point. So -3, 5, let's say -3, 5 is right here. And again, the picture is important, but not as important as maybe in the past. -3, 5 is here. That's going to be point R. O is at 2, 5. So we'll go 2 units to the right and 5 units up as well. So this is coordinate O, 2, 5. This is O. N is at 4, -2. So 4 units to the right, 4, and then 2 units down. Let's say that that's here. That's 4, -2, and that's coordinate N. And then the last coordinate is at -3, -6. So 3 units to the left, 1, 2, 3, and 6 units down. So that one's somewhere, let's just say down here. And this is coordinate A, which we're calling it -3, -6. So this is our figure, all right? We're trying to find perimeter. Now, perimeter, again, is distance around an object. So what we're looking for is this length. We're looking for this length. We're looking for this length. And we're looking for this length. Now, 2 of these are actually easier than others to find. And if you guys are looking at this, you can probably see that the distance from R to O is a straight line distance. It's completely horizontal because there's no change in the Y values. There's no change from 5 to 5. So all we need to be thinking of is how far -3 is from 2, which hopefully you can do that math in your head. -3 to 2, that's a distance of 5 units. Okay. The other one that's relatively intuitive in this problem is the distance from coordinate R to coordinate A, because of the fact that there's no X change. X is -3 here and X is -3 here. So really the only thing we need to figure out is the distance from R to A is how far apart the number 5 is from -6. Okay. Well, 5, that takes 5 units to get here and 6 more units to get here. That would be a distance of 11. And again, we're dealing with units. So far in our problem, we've got R to O being 5 units. And we've got R to A being 11 units. So far, a pretty easy problem. Okay. Now we do have these other 2 sides. We need to figure out the distance from O to N, and we need to find the distance from N to A. So let's write those down. O to N and N to A. Now, there's a couple different ways to approach it. All right, we could use that formula that we used yesterday, the distance formula, which looks something like this, where distance is equal to the square root of x2 minus x1 squared plus y2 minus y1 squared. We can use this formula if we'd like. The technique that I actually prefer is to just simply make some right triangles out of this. Okay. I've got a right triangle that's formed with the difference in my x values being the base and the difference in my y values being the height of the right triangle. So you guys can kind of see that right triangle that's formed here. Well, from 4 to 2, that's a difference of 2 units. So that means that this label would be 2. The difference in the y values, 5 to -2. Well, 5 is, I think, 7 units away from -2. That's going to be the height of the triangle. So we've got a 2 7 question mark right triangle here that's formed. And hopefully you guys can see that. So I'm going to use Pythagorean theorem to figure out distance from O to N. 2 to the second, 7 to the second is equal to c to the second power. This is 4. This is 49 is equal to c squared, and we can just work the problem back. This is 53 equals c squared. So that means c must be the square root of 53. Right? And again, that was distance from O to N. So I'm just going to write this in, and maybe I'll do some calculation later. But square root of 53 should be a little bit bigger than 7 units away. But we've got 3 legs of this shape now. Now, for the last leg, the distance from N to A. In this situation, I'm not going to use the triangle technique. What I'm going to use is the actual formula, right? So we've got an x1, and again, it doesn't really matter which one you title x1, which one you title y1, y2 or x2 and y2 here. So let's use the formula for this one. Distance is equal to the square root of x2 minus x1. So that would be -3 minus 4. And we're squaring it. Plus y2 minus y1, so that's -3 minus -6 minus -2. Which, doing your math correctly, this is part of the reason why I like the triangle technique, honestly, is because I make mistakes on these all the time. All right, especially when you're dealing with negative numbers. So distance is then equal to the square root of, let's see, -3 minus 4 is -7 squared. Make sure when you're doing this on your calculator, you put this in parentheses, otherwise you may get an incorrect answer. Plus -6 minus -2, that's equivalent to -6 plus +2. -6 plus 2 is -4. And I'm going to square it. Again, bunch of negatives. That's part of the reason why I like the triangle technique. You'll get the right answer if you do everything right either way. But now we just do the math. D is equal to square root of, just one little hint, these will never be negative numbers when you square them. Negative times a negative is always a positive. But anyway, -7 to the second, that's 49. 4 to the second power, or -4 to the second power, is 16. So our distance is going to be the square root of these two numbers added together, 49 and 16. That's 50, 65. So distance in this situation is going to be the square root of 65. So I'll add that to my list up here, square root of 65. So this, again, is the square root of 65, which is about 8.1. Actually, I think we did this one in yesterday's lesson. Just for kind of argument here, this 8.1, I'm going to do square root of 53 on my calculator. 53 square root of that, reminder, it's same as raising it to the half power, is 7.3. 7.3. This is rounded to the nearest tenth. And now, since we are looking, the question, original question asked for the perimeter of this figure, we just add the numbers together. 5 plus 11, which again, if you want to use a calculator, go for it. 5 plus 11 plus 7.3 plus 8.1 gets us our perimeter of P equals 31.4 units. So again, kind of taking the concept of Pythagorean theorem and distance and applying it to, I wouldn't call it a real world question, but it is for sure a challenging question. Hopefully the video was helpful and you guys can maybe do this on your own. And if you tried it on your own, hopefully you got something close to what I did. All right, guys, have a good day.